Hello, Greg. Good afternoon.
Hey, Matt, how are you?
Yeah,
Sorry, I
hello.
just had this in the background.
Oh, no worries. How are you?
Oh,
Cool.
and hello, Matt.
Hello. How's it going today?
Yeah, going well.
Good.
Hello, Justice. Good afternoon.
Hello, everyone.
Yeah, hello, Sandy.
Sorry, I was on mute for some reason. I think this meeting is set up to mute you when you arrive. Hi, everyone. We are bang on time, so it's probably too soon to harass people to see if they'll join. But I do just want to check in with Foley.
Okay.
Foley is
Good
on his way
morning.
as well.
Morning. Good
Hello, Colin.
afternoon.
Yes. Okay. In the meantime, I'm going to get started. And I think Foley's very familiar with the opening of our session today anyway. Welcome to our Technical Steering Committee on 5th of February 2026, our second for the year. And we have a fairly short agenda today. But first, as always, our antitrust policy notice. All of our meetings and events are governed by the Linux Foundation's antitrust policy. If you are a Linux employee and you have questions, you can contact the Linux legal team. If you are not a Linux employee, hopefully you have a legal team of your own that you can contact. If you have any questions around antitrust and the Linux Foundation. Then for today, we only want to review. We have had a couple of internal sessions around this already with our PACES team. We are going to be talking about the Tazama Data Lakehouse integration and specifically how data is shipped from the Tazama core engine to the data lakehouse. I'm going to hand over to Saban and the team who have a presentation. So Saban, I'm going to stop sharing and then over to you and the team.
Sure. Thanks, Justice. I hope everybody can hear me and I'm audible.
Yes, I can hear you.
Great. Wonderful. So I've just put my screen on share, and I hope that's also visible by now.
Yes, it's come
Wonderful.
through.
Great. So I think Justice already gave you the agenda. It's basically the data lakehouse component that we have been working on together. There are several aspects to it. And the one area where we wanted to focus on and let you all know about the work we've been doing and a couple of decisions that have been taken or are being taken in that area that need probably guidance from this forum as well, specifically relevant to the part of ingestion. Before we go into the core problem itself, I'll take a couple of minutes to acquaint you with the context, with the landscape that is in place, and then we'll go into the specific area of focus. Um, when we talk about the data lakehouse itself, it serves one as a traditional warehouse would, as it does in any enterprise context. But this lakehouse is also the source for us for our analytics and a lot of the BI and visualizations that we've been working on, both as a standalone analytics component with Jupyter Hub, but also as visualizations and analytics that are supposed to show up in our case and investigation management module. So the data that goes in there, what data goes in there, how it gets there. Those are different considerations Justice and our team we've been going through lately. To understand the downstream part of it first, that is all the components that come together to make this landscape. Ultimately, the data has to go. The destination is Hoodie. That's where our lakehouse resides. In order to get data there to the destination from different sources, and also one is disparate sources, the other is also disparate types of data. We have both unstructured as well as structured data going through our pipelines. So we rely on several components that we have integrated and set up pipelines to make this data flow. There is an unstructured data component that depends on CouchDB, Apache Tika, and Solr, that entire chain to make it work. And when it comes to the structured data, and when we say structured data, this is where we mean transactional histories, events, entities data, data that resides in the ODS, data that resides in the case and investigation management system database. That's what we're calling structured data. That has to flow to the lakehouse as well. In order to do that, a core component in this entire end-to-end pipeline or chain is Apache NiFi. That's where we set up our pipelines. That's where we set up either the logic for the push or the pull. What actually goes to Hoodie travels through NiFi. And that is the area where I think we're going to focus in today. Right now, one aspect of this entire end-to-end value chain was when we have to take data from our structured sources, how does that data actually get to Hoodie? Right now, you have different options there. You have an option. You can say that okay, we have these tables. Do we go pull data from there, or at the time of writing data to the ODS, do we push data to NiFi? Does NiFi periodically go get this data? So this is the area where we were really deliberating in. When we got into the nitty-gritties of it, we fundamentally found ourselves faced with two approaches. Approach one was that throughout the entire Tazama core ecosystem, wherever data that has to go to the lakehouse is generated, is intercepted, or is formulated, while we are pushing it or we are writing it to the ODS, we push it to NiFi as well. That was one option. There was also another option that you write data to the ODS and NiFi can go pull that data or pull that data from the ODS. We didn't go down that approach because that violates one of our design principles. We don't want transactional load or any additional load on the primary ODS, right? Because that has to be lean and clean and has to serve its primary function. So we didn't really go into that approach. But the first key approach was basically streaming data to NiFi in real time. That had its pros, that had its cons. I won't go into those just now because I really want to get to the meat of it. But if you want to come back to it and there are questions, I'd be more than happy to take those. So this was approach one. And what you really need to understand about approach one was that it's basically streaming of data to two destinations at the same time. The ODS itself, where we have to commit the data, but also to the lakehouse in real time. Approach two, which is basically the approach we've gone for ultimately, because it serves a larger purpose, is that you don't stream data from the core itself. You don't try to do that. You pretty much keep the Tazama core as it is today, that as you go through the different stages of the core doing its job, you write your data to the ODS or you write your data to the case and investigation management database. But what you rely on is basically replication that is provided by Postgres itself. But that requires you to do a couple of things. But what we're essentially saying is that data will go to the lakehouse. Yes, but rather than from the primary ODS, rather than using the primary database for that purpose, we have a standby database, which, and this is the important part, is leveraging replication that is provided by the Postgres framework. Our motivation for going down this approach is twofold. One, this is a pretty standard pattern that you'll see across most enterprise systems. And even when you go to even when you go to far larger or perhaps mainstream database applications like Oracle, like MySQL, etc., all of those provide, albeit paywalled, but replication and streaming services. The same is true for Postgres, and we were cognizant to make sure that we're not going down a road where we limit ourselves behind a paywall or something like that. But what we're essentially relying on here is an LSM mechanism, a log shipping mechanism. In the case of Postgres, that they call it WOL, write ahead log. And what that ensures is that the application writes to its primary ODS. You have a secondary database, which is, for all intents and purposes, a standby database. It's you can configure it to be read-only, write as well, but in our framework, we're going to be setting this up as a read-only database. And this operates as a mirror of the primary database. And that is the database that is essentially going to be streaming data to NiFi, or will be pulled by NiFi depending on different pipeline configurations, and will serve as the source of data or the structured data that ultimately goes into our lakehouse. There's one primary reason to do this, and I'll just explain that before I pause for taking some comments and questions, is that this solves another significant aspect of a Tazama deployment that we see should be considered and catered for, is that while the purpose of doing all of this was to serve writing to the data lakehouse or identifying a source for writing to the data lakehouse that doesn't affect performance, this also solves the inevitable problem of having a highly available data store in any Tazama deployment. What I mean by that is, if we anticipate deploying Tazama in an enterprise environment where there is significant load, without a doubt, there will be requirements to have high availability across all layers. That means having high availability on the application. That means having high availability for data in transit and also high availability for data at rest within site as well. I'm not talking about across site. So if you have your two sites, your primary and your DR, then even within your primary, you would want a highly available primary environment. And so following this design pattern sets us up nicely that if you have log streaming replication enabled within site across two servers, you have an ODS and a standby ODS as well. And then the jump from having a warm standby to a hot standby, at least at the data layer, is fairly simple. We would, of course, need application tweaking for that, no way around that, but at least from a structural point of view, that is available. So that was also a significant motivation for going down this approach. And so just to summarize what we're saying is, we started with identifying a solution to taking data into our data lakehouse. We wanted to do it in a manner that didn't affect the primary ODS in any way, in terms of its availability or in terms of its performance. So what we've done is we've used Postgres framework, the write ahead log mechanisms, to set up a standby server, a standby database. And that standby database basically serves as the source for the lakehouse. And in the larger sense, it would also serve as a backup for the primary database itself. And so I'll stop there. And if there are any questions or comments on this, I think I take those before moving forward.
Maybe I have one observation just to fill in from the Tazama product side. The previous option where we could, in theory, have used NATs as a mechanism to onwards route the data to the data lakehouse, would require changes to the Tazama core system itself. This solution does not appear to require any changes to the core. It is a straight database to database replication using, I believe, a well-known pattern, and a pattern that was specifically created for this purpose as well. So it also helps with robustness and resiliency and redundancy in your data infrastructure. And we are basically piggybacking off that functionality to replicate the database for the data lakehouse. That seems to me to be a more efficient way of implementing the replication rather than having to change the core product and also trying to invent our own data rail for it. But that's just an observation from the product side. I'm hoping that there would be maybe slightly more technical feedback from our technical steering committee today as well. This is a fairly technical solution that we are proposing, so hopefully somebody has a has a comment. Greg, Foley, Matt, anything from the rest of the TSC?
Yeah, you have my opinion already on all this, so I agree.
Cool. Thanks, Greg.
It also makes sense to me to try and use a different channel. Using NATs for streaming data, it does not sound good to me. So I think something that, as was mentioned, we need to keep in mind to keep the existing Tazama real time. Anything that touches the real time side of things, we don't want. So I think that happens after or separately, I think is the right way to go.
Thanks, Foley.
So just quickly, I think I'm okay. I wanted to get a sense for where we're serving data from for case management and investigations. Is that sort of out of the lakehouse, or is that sort of, and just considered analytics, or is that considered more?
Yeah. Matt, that's more the operational data source, so that's going to be the CIMS portion.
Okay.
Maybe also just to expand on that a little bit, the case management system itself will firstly receive data directly from the transaction monitoring service. So all of the core evaluation data gets shipped to the data to the case management system as an alert. But the alert itself only has a very sparse view of the overall data ecosystem that we are using, even inside the Tazama core system. So we expect that there will be enrichment of that data through data that is sourced in the data lakehouse, and data can be added to the data lakehouse from other data sources in the customer's ecosystem. So they can build data propagation for KYC information or account information, customer onboarding information, any other information that they feel might be useful could be routed to our data lakehouse. And then from there, it could be exposed to the case management system. So the case management system is likely going to be the largest operational consumer of data out of the data lakehouse.
Okay. Got it. Okay. So yeah, I was just trying to get a sense of whether from a design standpoint, we were thinking of case management more as analytics or more as sort of straight operations. And it sounds like analytics, which I think is fine.
Yeah.
Yeah. Okay. Good. I'm good. Thanks.
Thanks, Matt. Any other comments from anybody in the audience before we hand over back to Saban to continue? All right, Saban, sounds like it's back to you.
Yeah, then I have good news because I don't really have much more. This is in general the principle that we wanted to present and just get alignment on. And if we have alignment, then obviously the next steps for us are to complete a implementation of this and just give everybody an overview of this working in practice.
Okay. That sounds great. I don't actually expect that we would see this back at the TSC unless you run into an issue where we somehow need to change the approach that you are proposing here. But if we wanted to put this to a quick vote to go ahead, just to cross our T's and dot our I's, I propose we accept. And then from our voting members, Greg and Matt and Foley. Foley's got a thumbs up.
Yeah, agree.
Matt's happy. And Greg's got a thumbs up. Okay, cool. Done. Signed on the dotted line. Thank you very much, Saban and the team. And then good luck with the implementation. I do not have any other business for the Technical Steering Committee today. We are 20 minutes in. If anybody has anything from the floor, you have about 10 seconds to raise your hand. Otherwise, we're going to call it there for today. All right. That's a wrap. Thank you very much, everyone. Enjoy your day and your evening.
Thank you.
Thank you, and thanks everyone.
Thank you.
Bye.
Bye.